Somewhere in the depths of space, billions of light years away, there are cosmic beasts so hungry and so powerful that they can outshine every single star in their galaxy combined. We're talking about quasars, and they represent one of the most mind-bending phenomena in our universe. When astronomers first spotted these mysterious objects back in the 1960s, they were completely baffled. Through their telescopes, quasars looked like ordinary stars, just tiny points of light scattered across the night sky. But there was something deeply wrong with this picture. These stars were impossibly bright and impossibly far away. How could something so distant shine so brilliantly that we could still see it from Earth? The answer turned out to be far stranger than anyone had imagined. These weren't stars at all. They were the blazing hearts of ancient galaxies, powered by the most extreme objects in the universe, supermassive black holes. Imagine a black hole so massive that it contains the weight of billions of our suns, all crushed down into a space smaller than our solar system. Now picture this cosmic monster sitting at the center of a galaxy, surrounded by a swirling disk of gas and dust that's spiraling toward its doom. As this material falls toward the black hole, something incredible happens. The gas gets compressed and heated to temperatures of millions of degrees. It starts glowing brighter than anything else in the universe. The friction and magnetic forces in this cosmic whirlpool create jets of plasma that shoot out at nearly the speed of light, extending for thousands of light years into space. The energy released is so immense that it can power the equivalent of 1 trillion suns. This is what we call a quasar. It's essentially a supermassive black hole that's having the biggest feast of its life. Here's what makes this even more fascinating. The quasar 3C273, which was one of the first ones discovered, sits about 2.5 billion light-years away from us. Despite this unimaginable distance, it's still bright enough that amateur astronomers can spot it with a decent backyard telescope. Think about that for a moment. You're seeing an object that's so far away that its light has been traveling toward Earth since before complex life even existed on our planet. But here's the really wild part. When we look at quasars, we're essentially looking back in time. The most distant quasars we've found show us the universe when it was just a baby, less than 1 billion years old. These cosmic lighthouses are like time machines, giving us a glimpse into the chaotic early days of the cosmos, when galaxies were still forming and black holes were growing at an almost unbelievable rate. The connection between quasars and supermassive black holes solved one of astronomy's greatest puzzles, but it also raised even bigger questions. How did these black holes get so massive so quickly? And why don't we see quasars everywhere we look? The answer lies in the feast or famine lifestyle of these cosmic monsters. A quasar only shines when its black hole has something to eat. When there's plenty of gas and dust falling into the black hole, you get this spectacular light show. But eventually, the black hole consumes everything nearby, and the quasar goes dark. This is exactly what happened to the supermassive black hole at the center of our own Milky Way galaxy. Sagittarius A star, as astronomers call it, is currently sleeping. It's still there, still incredibly massive, but it's not actively feeding. Our galaxy's center is relatively quiet compared to these distant cosmic fireworks. The story of quasars teaches us something profound about the universe. Even the most violent and extreme phenomena play a crucial role in shaping the cosmos. These aren't just cosmic oddities. They're the architects of the universe as we know it. Back in the 1960s, astronomers thought they had stumbled upon the weirdest stars in the universe. Picture this. You're scanning the night sky with your telescope, cataloging what you think are ordinary stars, when suddenly you notice something that doesn't make sense. These particular stars are sitting in places where no star should be able to shine that brightly. The scientists of that era found themselves facing a puzzle that would keep them awake at night. These mysterious objects looked exactly like stars through their telescopes, just tiny pinpricks of light scattered across the cosmos. But when they measured how far away these objects were, the numbers were absolutely staggering. We're talking about distances so vast that the light from these stars had been traveling toward Earth for billions of years. Here's where things got really strange. If these objects were truly as far away as the measurements suggested, then they would have to be producing an almost unimaginable amount of energy to appear so bright in our telescopes. We're not talking about the energy of 1 star or even 100 stars. These mysterious objects were pumping out energy equivalent to 1 trillion suns all burning at once. The breakthrough came when astronomers realized they weren't looking at stars at all. They were seeing something far more extraordinary: the blazing hearts of entire galaxies. These objects, which came to be called quasars, short for quasi-stellar radio sources, were actually active galactic nuclei. Think of them as the cosmic equivalent of a giant furnace sitting at the center of a galaxy, burning so bright that they completely outshine the billions of regular stars around them. But what could possibly create such incredible amounts of energy? The answer lies in one of the most elegant and terrifying mechanisms in the universe: the accretion disk. Imagine a cosmic whirlpool made of gas and dust, spinning around a supermassive black hole at speeds that approach the velocity of light itself. This isn't just any ordinary whirlpool, though. The material in this disk is being heated to temperatures of millions of degrees by the incredible friction and gravitational forces at play. As the gas spirals inward toward its inevitable doom, it glows with an intensity that can be seen across the entire observable universe. This superheated material forms what astronomers call an accretion disk, and it's this disk that creates the spectacular light show we call a quasar. The black hole at the center acts like a cosmic engine, converting the mass of infalling material into pure energy with an efficiency that makes our most advanced power plants look like candles in comparison. What makes this discovery even more amazing is just how visible these distant powerhouses can be. Take 3C273, for example. This quasar was one of the first to be properly identified, and it sits about 2.4 billion light-years away from us. That's a distance so vast that if you could somehow travel at the speed of light, it would still take you 2.4 billion years to reach it. And yet, despite this mind-boggling distance, 3C273 is bright enough that you can actually spot it with a decent amateur telescope from your backyard. Think about what that means for a moment. You're looking at an object that's so far away that when its light first started its journey toward Earth, our planet was still in the very early stages of developing complex life. The light you're seeing tonight left that quasar when the most advanced life forms on Earth were probably just simple bacteria floating in ancient oceans. This incredible brightness across such vast distances tells us something profound about the scale and power of these cosmic phenomena. Quasars represent some of the most energetic processes in the entire universe, and they're giving us a window into understanding how galaxies form, grow, and evolve over cosmic time. The story of discovering quasars reminds us that the universe is full of surprises, and sometimes what looks like the most ordinary thing can turn out to be the most extraordinary phenomenon we've ever encountered. Every single quasar in the universe is hiding a secret at its very heart. And that secret is a monster so massive it defies imagination, a supermassive black hole weighing billions of times more than our sun. Now, here's where the story gets fascinating. These cosmic giants don't just sit there doing nothing. When matter starts falling toward one of these supermassive black holes, something incredible happens. The gas gets squeezed and heated up by friction as it spirals inward, reaching temperatures of millions of degrees. At those extreme temperatures, the gas begins to glow so brilliantly that it outshines entire galaxies filled with hundreds of billions of stars. Think of it like a cosmic lighthouse beacon, sending its light across the vast darkness of space for billions of years. But here's the catch. Without a steady supply of this cosmic fuel, the quasar simply shuts off. The light fades, and the show is over. This is exactly what happened right here in our own galaxy, the Milky Way. At the center of our cosmic home sits a supermassive black hole called Sagittarius, a star. But today, it's essentially sleeping. This giant weighs about 4 million times more than our sun, yet it barely whispers compared to the roaring quasars we see in distant galaxies. Why? Because it ran out of food. Let me paint you a picture that might help this make sense. Imagine a cosmic drain in your cosmic bathtub. If you let water trickle down slowly, it barely makes any noise at all. But what happens if you plug that drain, let the tub fill up completely, and then suddenly pull the plug? The water rushes down with tremendous force, creating a loud whoosh and lots of turbulence. That's essentially how a quasar is born. When enormous amounts of gas and dust suddenly become available to a supermassive black hole, maybe from a galaxy collision or a massive cloud of cosmic material. All that matter rushes toward the black hole at once. The result is a spectacular cosmic fireworks show that can be seen from billions of light years away. But here's what makes this story even more remarkable. Scientists have discovered that almost every large galaxy in the universe has one of these supermassive black holes at its center. Some are actively feeding and shining as quasars, while others, like our own Sagittarius A star, are quietly waiting for their next meal. The relationship between these black holes and their host galaxies is incredibly intimate. The black hole doesn't just live in the galaxy, it actually helps shape how the galaxy grows and evolves over billions of years. When a quasar is active, its powerful jets of energy can push gas and dust around throughout the entire galaxy, either triggering new star formation or shutting it down completely. What's truly mind-boggling is that some of these supermassive black holes grew to their enormous sizes when the universe was still very young, less than 1 billion years after the Big Bang. How they managed to gain so much weight so quickly remains one of the greatest puzzles in astronomy today. So the next time you look up at the night sky, remember that somewhere out there, cosmic monsters are putting on the greatest light show in the universe, powered by the simple act of falling matter heating up as it spirals toward its doom. And right here at home, our own sleeping giant patiently waits, perhaps for the day when our galaxy collides with Andromeda in about 4.5 billion years, potentially awakening it from its long slumber. Here's something that will absolutely blow your mind. When you look at a quasar through a telescope, you're not just seeing a distant object, you're literally looking back in time. And I mean way, way back. These cosmic beacons are so incredibly bright that we can spot them even when they're 12 billion light years away from us. Now, let that sink in for a moment. When light left those quasars to begin its journey toward Earth, our universe was just a baby, only about 10% of its current age. We're talking about a time when the cosmos was barely 1.5 billion years old. Think about what this means. Every time astronomers point their telescopes at these distant quasars, they're essentially becoming time travelers, peering into the universe's childhood. It's like finding a photo album from when your great-great-great-grandmother was a toddler, except we're talking about the entire universe. These ancient quasars are living fossils, cosmic archaeology at its finest. They're telling us stories about how the very first galaxies came to life in the early universe. Back then, everything was different. Galaxies were smaller, more chaotic, and much more active. There was plenty of gas and dust floating around, providing abundant fuel for these supermassive black holes to feast upon. What's remarkable is that some of the most distant quasars we've discovered formed when the universe was still emerging from what astronomers call the cosmic dark ages. This was a time when the first stars were just beginning to light up the darkness, and the universe was transforming from a cold, empty place into the vibrant cosmos we see today. One of the most fascinating things about studying these ancient quasars is how they challenge our understanding of cosmic evolution. Some of these early supermassive black holes were already incredibly massive, weighing billions of times more than our sun, when the universe was still very young. It's like finding a fully grown oak tree in what should be a nursery full of seedlings. Dr. Jane Green, an astrophysicist at the Massachusetts Institute of Technology, puts it beautifully when she says that quasars are like lighthouses in the cosmic ocean, guiding us through the history of the universe. Just as sailors once used lighthouses to navigate treacherous waters, astronomers use quasars to navigate through the vast expanse of cosmic time. But here's where the story gets even more intriguing. As we look at quasars at different distances, and therefore different times in cosmic history, we can actually watch how the universe evolved. The most distant quasars show us a wild, chaotic early universe full of galactic mergers and intense star formation. As we look at closer, more recent quasars, we see a universe that's becoming more organized and settled. It's like watching a time-lapse movie of cosmic evolution, frame by frame. The early universe was like a bustling construction site, with galaxies colliding and merging, black holes growing rapidly, and stars forming at breakneck speed. But as billions of years passed, things began to calm down. Galaxies spread apart, the fuel for quasars became scarce, and the universe entered a more peaceful phase. What's truly amazing is that by studying these cosmic time capsules, we're learning not just about the past, but also about our own future. The patterns we see in quasar evolution help us understand how our own Milky Way galaxy formed and evolved over billions of years. So the next time someone tells you that time travel is impossible, you can smile and tell them about quasars. Every night, astronomers around the world are using these brilliant cosmic beacons to journey back billions of years, watching the universe grow up from a cosmic infant into the magnificent cosmos we call home today. Every cosmic party eventually comes to an end, and quasars are no exception to this universal rule. Picture this. After millions of years of feasting on gas and dust, a supermassive black hole finally devours everything within its reach. The brilliant quasar that once outshone billions of stars suddenly dims and fades away like a magnificent firework that has consumed its last spark of light. But here's the fascinating part. This isn't death. It's more like entering a deep cosmic sleep. The supermassive black hole doesn't disappear or shrink away. Instead, it remains there in the galaxy's heart, now dormant and quiet, patiently waiting for its next meal to arrive. Think of it like a massive predator that has cleared out all the prey in its territory and now sits still, conserving energy until new opportunities present themselves. This process mirrors something surprisingly familiar in human experience. Imagine a bustling industrial city that suddenly loses its main factory or economic driver. Without that constant flow of resources and activity, the entire place enters a quiet phase. The infrastructure remains, the potential is still there, but the energy and vibrancy have temporarily disappeared. That's exactly what happens to galactic cores when their quasars shut down, just like our own Milky Way galaxy today. Our galaxy actually hosts one of these sleeping giants right at its center, Sagittarius. A star, our supermassive black hole, weighs about 4 million times more than our Sun, yet it sits remarkably quiet compared to the raging quasars we observe in distant galaxies. Scientists believe it was likely much more active billions of years ago, probably shining as a bright quasar when the universe was younger and gas was more abundant. The really intriguing question that keeps astronomers awake at night is whether these dormant black holes can wake up again. The answer appears to be yes, under the right circumstances. When galaxies collide or merge, or when fresh streams of gas somehow find their way to the galactic center, these sleeping monsters can roar back to life. The gravitational dance of merging galaxies can funnel enormous amounts of material directly into the black hole's waiting mouth, potentially reigniting the quasar phase. This brings us to a cosmic event that's actually heading our way. In about 4.5 billion years, our Milky Way is set to collide with the Andromeda galaxy in what astronomers call a galactic merger. During this slow-motion cosmic crash that will unfold over hundreds of millions of years, vast amounts of gas and dust will be stirred up and redirected. Some of this material could very well end up feeding both galaxies' central black holes. The possibility is genuinely exciting from a scientific perspective. Sagittarius, a star, could potentially transform from its current quiet state into an active, blazing quasar once again. If this happens, the night sky would become dramatically different for any beings around to witness it. The galactic center would glow brilliantly, possibly visible even during daytime, fundamentally changing how the galaxy looks from the inside. Of course, this reawakening wouldn't be without consequences. Quasar activity brings intense radiation and powerful jets of material shooting out from the galactic center. These jets can travel for hundreds of thousands of light years, potentially affecting star formation throughout the galaxy, and even influencing planetary atmospheres in extreme cases. The cyclical nature of quasar activity reveals something profound about the universe itself. Nothing stays the same forever, not even the most extreme cosmic phenomena. These periods of activity and dormancy suggest that galaxies themselves go through life cycles, with active phases of growth and star formation, followed by quieter periods of relative stability. What makes this even more remarkable is that we're essentially looking at a cosmic recycling system. The same supermassive black holes that powered the brightest objects in the early universe continue to exist today, ready to spring back into action when conditions are right. It's like having ancient engines of creation scattered throughout the cosmos, occasionally starting up to reshape their galactic neighborhoods. The end of a quasar phase isn't really an ending at all. It's more like the universe hitting a pause button, setting the stage for the next act in an ongoing cosmic drama that spans billions of years. Let's address the question that probably crossed your mind while learning about these cosmic powerhouses. Could a quasar actually harm our planet? It's a legitimate concern when you consider the sheer scale of energy these objects unleash into space. Quasar jets are genuinely terrifying in their scope and power. These streams of superheated plasma and radiation can stretch across millions of light years, carrying enough energy to sterilize entire planets along their path. When a quasar fires up, it doesn't just light up its immediate neighborhood. It sends out deadly radiation that can affect solar systems incredibly far away. The jets move at speeds approaching the speed of light, and anything unfortunate enough to be directly in their path faces complete annihilation. But here's where we can all breathe a collective sigh of relief. The closest known active quasar sits about 600 million light-years away from us. To put that distance in perspective, that's roughly 6,000 times farther than the Andromeda Galaxy, our nearest major galactic neighbor. Even if this distant quasar pointed its jets directly at Earth, the radiation would be so diluted by the time it reached us that it would barely register above the cosmic background radiation we experience every day. Our location in the Milky Way also works in our favor. We're positioned in what astronomers sometimes call the galactic suburbs, about 26,000 light-years away from the galactic center where Sagittarius A star resides. This distance provides us with a comfortable buffer zone, even if our central black hole were to suddenly spring back to life. However, let's explore a truly mind-bending hypothetical scenario that helps illustrate just how powerful these objects can be. Imagine if we replaced our relatively modest Sagittarius A star with one of the most massive quasars ever discovered, known as TON 618. This cosmic monster weighs in at approximately 66 billion times the mass of our Sun, making it one of the most massive objects ever found in the universe. If such a behemoth suddenly appeared at the center of our galaxy, the consequences would be immediate and catastrophic. The intense radiation pouring out from this quasar would reach Earth in about 26,000 years, but once it arrived, our planet would be vaporized almost instantly. The atmosphere would be stripped away in seconds. The oceans would boil off into space, and the very rocks beneath our feet would melt from the incredible energy bombardment. Fortunately, this scenario exists purely in the realm of cosmic horror fiction. Astronomers have carefully studied the behavior of supermassive black holes in our galactic neighborhood, and the evidence strongly suggests that none of them have the appetite or the available fuel to transform into active quasars anytime soon. The gas and dust supplies that would be necessary to feed such a transformation simply aren't present in sufficient quantities. Even when our galaxy eventually collides with Andromeda in about 4.5 billion years, the process will unfold slowly over hundreds of millions of years. While this merger might indeed provide enough material to reactivate Sagittarius A star, astronomers predict that any resulting quasar activity would be relatively mild compared to the extreme examples we observe in the distant universe. The timing also works in our favor from a biological perspective. By the time any potential quasar activity begins in our galaxy, our Sun will have already started its transformation into a red giant star, fundamentally changing conditions on Earth regardless of what happens at the galactic center. The solar system as we know it will have already undergone dramatic changes long before any quasar threat could materialize. There's also a comforting aspect to the directional nature of quasar jets. These beams of energy are typically focused along the poles of the spinning black hole, creating narrow cones of destruction rather than spherical waves of radiation. Even if a quasar did activate relatively nearby, the chances of Earth being directly in the path of these jets would be astronomically small. Scientists continue to monitor our galactic center and other nearby black holes for any signs of increased activity. Modern telescopes can detect even subtle changes in radiation levels or gas accretion patterns that might signal the beginning of more active phases. So far, all observations confirm that we're living in a remarkably stable and quiet galactic neighborhood. The reality is that we face far more immediate cosmic threats than quasars. Asteroid impacts, gamma-ray bursts from collapsing stars, and even the eventual death of our own Sun pose much more realistic concerns for the future of life on Earth. Quasars, despite their incredible power, remain safely distant curiosities that allow us to study the extreme physics of the universe without putting our own planet at risk. So while quasars deserve our respect and scientific attention for their role in shaping the cosmos, they don't deserve a place on our list of things to worry about. We can continue to marvel at these cosmic lighthouses from our safe distance, appreciating their beauty and power without losing sleep over their potential threat to our cosmic home. Picture this. You're trying to study the most violent, powerful objects in the entire universe, but they're sitting billions of light years away, hidden behind clouds of cosmic dust. It's like trying to examine a roaring bonfire through thick fog while standing on the other side of a football field. That's exactly the challenge astronomers faced when they first discovered quasars back in the 1960s. But here's where human ingenuity kicks in. Scientists at NASA and the European Space Agency realized they needed special tools, cosmic detectives, if you will, to hunt down these elusive beasts. They couldn't just use regular telescopes because quasars don't just shine in visible light. These monsters scream across the entire electromagnetic spectrum, from radio waves to gamma rays. Enter the Chandra X-ray Observatory, launched in 1999. Think of Chandra as a cosmic thermometer that can measure the temperature of gas heated to millions of degrees. When matter spirals into a supermassive black hole, friction heats it to such extreme temperatures that it glows in X-rays. Chandra can see this invisible fire, revealing the feeding frenzy happening around these black holes. It's like having X-ray vision that lets you see the skeleton of the universe's most violent processes. But even Chandra had its limitations. Cosmic dust acts like a thick blanket, hiding many quasars from our view. That's where the James Webb Space Telescope comes in, humanity's newest cosmic archaeologist. Launched in 2021, Webb sees an infrared light, which can penetrate through dust clouds like they're made of tissue paper. Suddenly, quasars that had been hiding for billions of years were revealed, like finding hidden treasure in an attic you thought was empty. The discoveries started pouring in almost immediately. In 2023, Webb spotted something that made astronomers question everything they thought they knew about black hole growth. There, in images taken from the early universe, was a quasar powered by a black hole that formed just 470 million years after the Big Bang. To put that in perspective, if the universe's entire history was compressed into a single year, this black hole would have appeared in early February. This discovery was like finding a fully grown oak tree in what should have been a nursery of seedlings. How did these black holes grow so massive so quickly? It's one of the biggest puzzles in modern astronomy, and it's forcing scientists to rethink how the first galaxies formed. But the story doesn't end there. Looking toward the future, astronomers are preparing an even more revolutionary tool. In 2030, the Laser Interferometer Space Antenna, known as LISA, will launch into space. This isn't just another telescope, it's something entirely different. LISA will listen to the universe. You see, when massive black holes merge, they create ripples in the fabric of space and time itself. These gravitational waves travel across the cosmos like cosmic whispers, carrying stories of collisions that happened billions of years ago. LISA will be sensitive enough to detect these whispers from the dawn of time, potentially revealing how the very first supermassive black holes came to be. Imagine being able to eavesdrop on conversations between black holes that happened when the universe was still in its infancy. That's essentially what LISA will do. It might finally solve the mystery of how quasars became so powerful so early in cosmic history. The work these space-based archaeologists are doing is extraordinary. Every observation is like uncovering ancient artifacts that tell us about the universe's violent youth. The deeper we look into space, the further back in time we travel, finding baby galaxies nursing their first supermassive black holes. What makes this detective work even more fascinating is how these discoveries connect to our own cosmic neighborhood. The supermassive black hole at the center of our Milky Way, Sagittarius A star, was once likely an active quasar itself, billions of years ago. The atoms in your body, the calcium in your bones, the iron in your blood, may have once been heated to millions of degrees in the accretion disk of a distant quasar. These cosmic monsters we're hunting aren't just distant curiosities. They're the architects of everything we see around us, the sculptors of galaxies, and the recyclers of cosmic material. Understanding them means understanding our own cosmic heritage, our place in this vast, interconnected universe where even the most violent phenomena play a role in creating the conditions for life itself. Here's something that might blow your mind. Every breath you take, every heartbeat, every thought racing through your head right now exists because of cosmic violence that happened billions of years ago. The quasars we've been talking about aren't just distant lighthouses scattered across the universe. They're the master architects of everything we see around us, cosmic sculptors that literally shape the galaxies we call home. Think about it this way. Imagine you're watching a master artist at work, but instead of using a chisel and marble, they're wielding jets of superheated plasma traveling at nearly the speed of light. These jets, fired from quasars, can stretch for millions of light years across space. They slam into clouds of gas and dust with such tremendous force that they can either trigger the birth of new stars or completely shut down star formation for millions of years. It's like having a cosmic gardener who decides where flowers can bloom and where they can't. Some regions of a galaxy get blasted with so much energy that all the gas gets blown away, creating vast, empty spaces where no new stars can form. Other areas get just the right amount of pressure, compressing gas clouds until they collapse and ignite into brilliant new suns. This process has been going on for over 12 billion years, ever since the first quasars lit up in the early universe. Every galaxy we see today, including our own Milky Way, bears the fingerprints of this ancient cosmic sculpting. The beautiful spiral arms of galaxies, the vast empty spaces between galaxy clusters, even the regions where planet-forming elements are most abundant. All of these features exist because quasars shape them over cosmic time. But here's where the story gets really personal, and I mean literally personal to you and me. The carbon atoms in your DNA, the oxygen you're breathing right now, the calcium in your bones, the iron flowing through your bloodstream, all of these elements were forged inside massive stars. And many of those stars lived their entire lives in galaxies that were shaped by quasar activity billions of years ago. Even more incredible is this. Some of the atoms in your body may have actually passed through a quasar's accretion disk at some point in cosmic history. Picture this scenario from 10 billion years ago. A massive star in a distant galaxy reaches the end of its life and explodes in a supernova, scattering its precious cargo of heavy elements into space. This cloud of star stuff gets caught up in the gravitational dance around a supermassive black hole. For perhaps millions of years, these atoms spiral inward, getting heated to temperatures of millions of degrees, glowing so brightly they can be seen from across the universe. But not all matter that approaches a black hole gets swallowed. Some of it gets flung back out into space by the quasar's powerful jets, now enriched with energy and mixed with material from countless other stars. This recycled star stuff eventually becomes part of new gas clouds, which collapse to form new generations of stars and planets. Fast forward billions of years, and some of those very same atoms end up on a small rocky planet orbiting a yellow star, becoming part of the chemistry that makes life possible. When you really think about it, quasars represent one of the universe's greatest paradoxes. They're simultaneously the most destructive and creative forces in the cosmos. On one hand, they can sterilize entire regions of galaxies, making them uninhabitable for eons. On the other hand, they're essential for spreading the heavy elements that make rocky planets and complex chemistry possible. Without quasars, the universe would be a much darker, emptier place. Galaxies would be smaller and less organized. The elements necessary for life would be trapped inside the cores of massive stars instead of being distributed throughout space. The beautiful cosmic web of galaxies and galaxy clusters that we see today simply wouldn't exist. This is perhaps the most profound lesson quasars teach us about the nature of existence itself. Even the most violent, chaotic phenomena in the universe can be forces of creation. Destruction and creation aren't opposites. They're dance partners in the cosmic ballet that's been playing out for nearly 14 billion years. Every time you look up at the night sky, you're seeing the handiwork of these ancient cosmic architects. The stars twinkling overhead, the planets in our solar system, the very ground beneath your feet, all of it exists because supermassive black holes once roared to life as quasars, reshaping the cosmos and setting the stage for everything that followed. In a very real sense, we are all children of quasars, inheritors of a universe shaped by forces so powerful they beggar the imagination, yet so essential that without them, none of us would be here to contemplate their legacy. Picture this. You're standing in front of the most powerful flashlight in the universe, one that can outshine an entire galaxy of hundreds of billions of stars. Scientists have been studying these cosmic beacons called quasars for over 60 years now, yet they still keep us awake at night with questions that seem impossible to answer. Here's what's really mind-boggling. We know that supermassive black holes power these quasars, but how did these monsters get so incredibly massive so quickly? Think about it this way. If you wanted to grow from the size of a grain of sand to the size of a mountain, that would take an enormous amount of time and material. Yet astronomers have discovered quasars that existed when the universe was just a baby, only 670 million years old. Their black holes already weighed billions of times more than our sun. It's like finding a fully grown oak tree in a field that was planted just last week. Even stranger, some quasars behave like cosmic light switches. They can flicker on and off within human lifetimes, sometimes dimming dramatically in just a few decades. Imagine if the sun suddenly became 10 times brighter, then went back to normal before you graduated college. That's essentially what we're seeing with these distant powerhouses. And honestly, it makes no sense according to our current understanding of how black holes should behave. But here's where things get really wild. Some physicists are starting to whisper about a controversial possibility that sounds like science fiction. What if not all quasars are powered by black holes? What if some of these cosmic lighthouses are actually fueled by something even more exotic, something we haven't discovered yet? There's this theoretical substance called strange matter that could potentially exist under the most extreme conditions imaginable. Unlike the ordinary matter that makes up everything we know, including our own bodies, strange matter would follow completely different rules. If it existed at the heart of some quasars, it might explain why these objects sometimes behave in ways that make astrophysicists scratch their heads in confusion. Of course, this is still pure speculation, the kind of idea that gets discussed in late-night conversations between scientists over coffee. But throughout history, some of our greatest discoveries started exactly this way, with someone daring to suggest that maybe, just maybe, we're missing something fundamental about how the universe works. The beauty of these unsolved mysteries is that they remind us how much we still have to learn. Every time we think we've figured out quasars, they surprise us again. It's like trying to understand a conversation in a foreign language where you only know half the words. You get the general idea, but the subtle nuances keep slipping away. What makes this even more exciting is that we're living in an era where new telescopes and detection methods are giving us unprecedented views of these distant objects. Who knows? Maybe tomorrow someone will observe something that completely changes our understanding of what quasars really are. So what do you think? Could there be forms of matter out there that we haven't even imagined yet? Sometimes the most fascinating discoveries come from the questions we're brave enough to ask, even when they seem impossible to answer. You know, as we reach the end of our cosmic journey together, I can't help but feel a sense of awe at what quasars really represent in the grand story of our universe. These incredible objects are like cosmic philosophers, teaching us profound lessons about the nature of existence itself. Think about it for a moment. Quasars show us that the universe is a place where the most violent and chaotic events can create the most breathtakingly beautiful phenomena. Picture a supermassive black hole, this invisible monster that devours everything in its path. Yet when it feeds, it creates a light show so magnificent that it can be seen across billions of years of space and time. It's like watching a storm at sea from a safe distance, where the raw power and destruction somehow transforms into something absolutely mesmerizing. These cosmic beacons remind us that even the most fearsome giants in the universe have their own life cycles, just like the smallest creatures on Earth. A quasar blazes brilliantly for millions of years, reshaping entire galaxies with its energy, and then gradually fades into quiet slumber as it runs out of fuel. It's humbling to realize that even objects powerful enough to outshine a trillion stars eventually grow old and tired. But here's what really gives me chills when I think about it. Right now, as you're listening to this, there's a sleeping giant at the heart of our own Milky Way galaxy. Sagittarius A star, our supermassive black hole, sits quietly in the galactic center like a dormant volcano. It's been peaceful for millions of years, but that doesn't mean it will stay that way forever. In about 4.5 billion years, something extraordinary is going to happen. Our Milky Way will collide with the Andromeda galaxy in a cosmic dance that will reshape both galaxies completely. When that happens, vast streams of gas and stars will be thrown around like leaves in a hurricane. Some of that material might fall toward our sleeping black hole, and if enough accumulates, well, our peaceful galaxy might suddenly have its very own quasar. Imagine future civilizations, if they exist, witnessing the awakening of our galactic center. They would see jets of plasma shooting out across thousands of light years, painting the sky with colors we can barely imagine. What we consider a quiet neighborhood today might become one of the most spectacular light shows in the local universe. It's a reminder that nothing in the cosmos stays the same forever. Stars are born and die, galaxies merge and evolve, and even the most peaceful corners of space can suddenly burst into cosmic fireworks. We're living in what astronomers call a relatively quiet epoch of the universe, but that's just one chapter in an incredibly long and dynamic story. Quasars teach us that beauty and violence, creation and destruction, order and chaos, aren't opposites in the universe. They're dance partners, constantly interacting to create the rich tapestry of cosmic evolution that surrounds us. Every atom in your body was forged in the heart of a star, and some of those atoms might have once been part of the swirling disk around a quasar billions of years ago. So the next time you look up at the night sky, remember that you're not just seeing a static picture. You're witnessing an ongoing story of cosmic evolution, where sleeping giants dream in the hearts of galaxies, waiting for their moment to wake up and remind the universe just how spectacular it can be. If you've enjoyed this cosmic journey as much as I have, I'd love for you to subscribe to Exploring the Universe. Hit that notification bell so you never miss our adventures through space and time. Give this video a thumbs up if it sparked your curiosity, and share it with anyone who loves pondering the mysteries of our incredible universe. Until next time, keep looking up and wondering what other secrets the cosmos has waiting for us to discover.